seismic waves arrive in Iceland, they're traveling very slowly through the subsurface. And this is somewhat unique to Iceland and a few other places in the world.
Iceland rises from the Atlantic like a place still deciding what it wants to become, shaped by fire below and ice above in a balance that never holds for long. When researchers entered a forgotten passage beneath its soil, they expected traces of human survival, not clues pointing deeper into the planet toward forces powerful enough to rewrite Iceland's entire origin story. The living island. Iceland's landscapes often look frozen in time, yet the ground beneath them rarely stays still for long, because the island straddles the mid-Atlantic ridge, where two massive tectonic plates drift apart in a slow but relentless motion. This separation allows heat from deep within the Earth to rise toward the surface, creating a chain of volcanic systems that continually reshape the terrain through eruptions, lava flows, and the silent accumulation of pressure beneath seemingly calm fields. Travelers often admire Iceland's glaciers and black sand coastlines without realizing that these features are constantly responding to the forces assembling below, whether through bursts of seismic activity or the steady release of geothermal heat that feeds the island's famous hot springs. Scientists who study Iceland frequently describe it as a natural laboratory, since few places offer such a direct window into the workings of the planet's interior. Measurements taken across the island show crustal thinning in some regions and thickening in others, revealing a hidden tug-of-war between stretching forces at the ridge and the upwelling of molten rock rising from below. This delicate balance can shift with little warning, producing eruptions capable of melting glacial ice in hours or sending ash clouds into skies far beyond Iceland's borders. Understanding this restless setting is essential because the soil that once seemed predictable has now revealed something far older and more mysterious, creating a puzzle that scientists never expected to confront. The uneasy past beneath the soil. The discovery that set this investigation in motion began quietly in the southern lowlands near Adi, where archaeologists from the Archaeological Institute of Iceland were conducting what appeared to be a routine survey of farmland shaped by centuries of volcanic deposition. The team expected to document surface features left behind by early settlers, yet the instruments they carried started returning unusual readings, suggesting hollow spaces where the geology should have been dense and uniform. When the researchers pressed metal probes into the ground, the soil responded with a muted echo that hinted at something unexpected beneath their feet, prompting a careful excavation that slowly peeled away the upper layer of earth. As the team worked deeper, they reached an opening that looked nothing like a natural fault or lava tube because its edges were too clean and its contours too deliberate. The first chamber revealed walls that showed signs of shaping by human hands, with chisel-like markings tracing patterns along the stone in ways that suggested intention rather than chance. The air inside carried the stale heaviness of a space long sealed from the surface, and beams of artificial light revealed the beginning of a passageway extending beyond the initial cavity. Each step into this darkened corridor raised questions about who carved it, how long it had been hidden, and why its construction differed so greatly from the typical dwellings used by Iceland's earliest inhabitants. What began as a simple archaeological task was turning into a deeper investigation, because the scale and complexity of the underground network implied a purpose that went beyond emergency shelter or short-term storage. Something about the craftsmanship hinted at a larger story waiting to emerge from the bedrock. The world of the Viking caves. As archaeologists mapped the chambers branching from the initial opening, they recognized architectural choices that aligned with the ingenuity of Iceland's earliest Norse settlers, who arrived around the late 9th century and adapted quickly to a land where timber was scarce and weather patterns could threaten survival. Instead of relying solely on turf and driftwood, these settlers sometimes carved directly into soft volcanic rock, creating spaces that offered insulation against wind, snow, and subarctic temperatures. The walls of these newly uncovered chambers bore repeating tool marks consistent with Iron Age chisels, and radiocarbon samples collected from soot impressions near the entrances placed their use firmly within the Viking Age. The larger rooms appeared intentionally leveled, suggesting communal functions such as food preparation, crafting, or shared shelter during severe storms. Narrow corridors connected these rooms in a layout more deliberate than anything expected from temporary refuge, indicating that the builders invested considerable effort into choosing the site, shaping the stone, and maintaining airflow through small carved vents that remained visible along certain passages. The craftsmanship displayed a deep understanding of Iceland's volcanic bedrock, demonstrating that these settlers worked not only with the landscape above them, but also with the geological structure beneath their settlements. However, as the team progressed deeper into the network, they found irregularities that did not fit neatly within Viking engineering traditions, including chambers that extended into formations older than the settlement period itself. Sediment layers within these deeper cavities suggested geological changes far older than any carved structure, blurring the line between human adaptation and Earth's natural evolution. This merging of cultural history with geological complexity set the stage for an even more surprising realization. The caves might be only the uppermost layer of a story that reached much further down into Iceland's past. Fragile stone and dangerous depths. The deeper researchers pushed into the network, the more they realized how precarious the environment had become over the centuries, because Iceland's volcanic bedrock, though initially firm enough for carving, changes subtly under constant exposure to water, temperature shifts, and seismic motion. Fine cracks formed by centuries of freeze-thaw cycles widened into hidden fractures, creating ceilings that appeared stable, yet concealed weakened layers, ready to collapse under the slightest disturbance. Archaeologists entering these chambers describe the unnerving sensation of hearing small grains of loosened stone fall in the distance, signaling that the entire structure had been slowly reshaped by natural forces long after its original builders abandoned it. To prevent accidents, scientists relied on ground-penetrating instruments and microseismic sensors capable of detecting vibrations that would otherwise escape human perception. These tools revealed pockets where the rock had thinned to dangerously brittle sheets, making certain pathways impassable until reinforced. Air quality presented another obstacle because oxygen levels tended to decline in sealed volcanic spaces, while carbon dioxide and other gases accumulated in invisible concentrations that could overwhelm explorers without warning. Each entry into the caves required a precise sequence of ventilation checks, structural assessments, and coordinated movement to ensure that even the smallest team could navigate safely. The challenges facing the researchers underscored how alive Iceland's subsurface truly is, because every tremor recorded above ground reverberated through the cavern system, subtly shifting its geometry. These hazards reminded the team that they were not simply studying history, they were working inside a landscape still being rewritten by the planet's internal forces, which hinted that the mysteries beneath Iceland extended well beyond human craftsmanship. The hidden continent theory. As archaeologists documented the human-made portions of the cave system, geologists analyzing measurements from the surrounding region realized that the underground story did not end with cultural history, because Iceland's crust displayed anomalies that challenged long-standing assumptions about how the island formed. Typical oceanic crust created along mid-ocean ridges measures roughly 7 kilometers thick, yet seismic surveys across Iceland consistently revealed sections exceeding 30 kilometers, a value far more consistent with continental crust than with seafloor basalt. This discrepancy raised questions that stretched beyond archaeology, suggesting that Iceland might sit atop remnants of an ancient landmass concealed beneath layers of volcanic material. Researchers from several European institutions proposed that when the North Atlantic opened around 60 million years ago, fragments of an older continent may not have fully broken apart or sunk, leaving behind a buried plateau now referred to as Icelandia. Gravity measurements, heat flow data, and seismic tomography supported the possibility of this thicker foundation, although the theory remained debated because volcanic hotspots can also produce elevated crustal thickness through repeated magma intrusion. The coexistence of both explanations created a scientific crossroads, prompting teams to re-examine assumptions about how mid-ocean islands grow and why Iceland's structure differs so dramatically from its neighboring ridge segments. What made the situation more compelling was the alignment between these crustal anomalies and the regions where volcanic activity appeared unusually intense, suggesting a deeper energy source shaping the island's evolution. This convergence of evidence pushed geologists to look farther below the crust, where they uncovered a phenomenon that reframed not only Iceland's origins, but also the behavior of the planet's interior. The mantle plume that shouldn't exist. When geophysicists expanded their investigation beneath Iceland's thickened crust, they detected a phenomenon far more unusual than continental fragments, because seismic waves traveling upward from the deep Earth revealed a mantle plume unlike any previously mapped in the North Atlantic. Using tomography techniques similar to medical imaging, researchers traced this plume to depths approaching 2,000 kilometers, placing its root near the boundary between the mantle and the core. Most mantle plumes originate shallower within the mantle's upper regions, yet this one appeared to rise from an extraordinary depth, with temperatures high enough to melt rock long before it reached the crust. Its unusual strength offered a compelling explanation for Iceland's towering volcanic output and its crustal thickness, since a plume of this intensity could feed continuous magma generation while uplifting the land above. Measurements of vertical displacement across Iceland showed subtle but persistent elevation gain in certain regions, suggesting that the plume does not simply passively feed eruptions, but actively reshapes the island's surface over geological time. This insight bridged two competing theories by revealing a mechanism capable of both thickening the crust and supporting the possibility of a buried continental platform. The plume's scale also reshaped scientific understanding of how heat moves through the planet, because a conduit reaching so deeply challenges existing models of mantle convection. Instead of behaving like a simple column of rising material, the Iceland plume may tap into lower mantle reservoirs, creating a dynamic system that influences volcanic behavior, seismic patterns, and crustal formation across a wide region of the North Atlantic. For researchers studying Iceland, the discovery signaled that the island's origins were part of a much larger and more enigmatic story hidden within Earth's interior. Iceland's shifting ground reminds us that the planet's deepest stories often wait beneath our feet. If you'd like to follow more journeys into hidden worlds and unanswered mysteries, subscribe, leave a comment with your thoughts, and join us as we explore the forces quietly reshaping our future.